Good afternoon. Good afternoon, and welcome to this lecture of electronics. I guess I'm audible properly, loud and clear. So we can start. Today we are going to start with a new topic that is actually related with your analog to digital converters. That is sample and hold circuit. So I guess that two unit have been almost completed by say Abhijit sir. And today I just want to refresh it. So my screen is visible, I guess. So I guess my screen is visible to you all. Is it visible? Anybody can unmute. Okay,
Yes, sir.
thank you. So we are going to study today this circuit that is called as sample and hold circuit. Let me introduce myself. Myself, Dr. Head and Associate Professor, Department of Electronics and today we are expected to complete this circuit which is called as sample and hold circuit. Now, why this circuit is required? So, we are going to study. Now, let us study what is actually analog and what is digital. So, analog is actually a curve which is shown over here in this graph. The function of time which goes on changing with respect to time is called as analog signal, right? And this analog signal uh, is being converted into digital form. Now, this is digital. So, this is converted with say digital bits. So we have converted this in 3 bits, right? So which is starting from 00, then 001, then 0010, 011, 101, 100, 101, 110, and 11. So likewise, so it is going to be converted in this fashion. So this is how digital signals are there. So we know that analog system, that analog which is converted, which is changing with respect to time is called as an analog signal, and the signal which is being digitized, which is converted into digital on and off, is this digital signal. So one particular point of this analog signal is to be converted in that specific digital code, right? So that is called as the digital system. So this is the example of digital analog system where we are going to transfer the analog signal, that those are electromagnetic waves which are being transferred by this antenna. Right. Similarly, we are now using this digital communication system where we are converting this analog signal into digital form, and these digital signals are being given to the computer, and these are being converted to the say analog to digital converter circuits, and then they are being transferred to the CPU, and this CPU is now going to broadcast this signal, this beats through this antenna. So we are now nowadays using all the digital sort of signals. So this is the basic difference between analog and digital signal, and this is what we mean when we use this analog signal. So we are having this analog signal over here, and we are sampling it, right? So we call it as the sample. So we are taking a bits at a particular interval of time. So those we call it as these samples. So we are converting these particular samples into that particular codes, digital codes, right? So that is what is done by this analog to digital converter. Now, the signal which is over here, this is to be converted into digital, right? So as you are able to see over here, we are missing some of the points. So here we have quantized, we have sampled it, but if you are able to see this, this lands in 110 and 111. It does not reaches to this point, that is 111, right? So what happens? We are not able to convert this portion of the signal into digital. So this is what is being told. So how to convert all these points? So for that we will require higher bits, or say higher bits of data. So rather going for this 3 bit of conversion, we can go more than that. That is for 4 bit, or say for 8 bits. So as you go on increasing the bits structure, then this whole signal can be quantized, or can be digitized. That is called as the digital signal, right? So yeah. So what we need to convert each and every point of this analog signal, which is changing with respect to time, to to a particular ports. Those we call it as the digital ports, right? So this job is done by the analog to digital converter, which we have already completed, I guess. So if you are able to see over here, now this signal which is being converted at this point, we miss all these points which is to be converted, right? Since we are using lower number of bits. To convert this also, we require that this is to be sampled properly. Now, during this time, what happens? The signal is too fast, and the analog to digital converter is little bit slow with comparatively as the signal is processed. Right? So, what happens? This signal is being say ignored, or say this signal is not being digitized by this that analog to digital signal, and after conversion of this point, it directly reaches to this point because after converting it requires this much of time. So for this, we require some circuit. Similarly, when I say, for example, if I say the students to write notes and I dictate that notes, right? But I dictate the notes too fast. So what happens? You are not able to write. So in that mean duration, what you require some circuit or uh, some circuit which can hold that signal at the time you are writing something. So you won't miss the signal. You won't miss the letters which I have pronounced and I have dictated to you to write. Right? So this particular job is done by that circuit that is called as analog to digital. Now, why we require this digital? So definition of digital is digital source produces a finite set of possible values. Right? An analog source produces an infinite set of possible values. So these are all the definitions. So these signals which are to be digitized, the analog signals that are to be digitized, are, are going to be are worked out by the analog to digital converters. Now, the signal is measurable quantity, example voltage, which bears information. Right? The analog signal contains a voltage which is changing with respect to time. Similarly, digital signal also contains that voltage. So it contains zeros and ones, where zero is supposed to be the ground and one is supposed to be the positive high voltage. Right? So this is how it goes on changing. So, but indirectly, it is having some or other type of electrical signal that might be voltage, that might be current. So, we are using voltage as this. So, noise is measurable quantity which carries undesirable interval. Now, this is one of the most important parameters which is to be taken care of. Right. So why digital? Why? Because it is less expensive circuits, privacy and security, small signals, and they can be converged into multimedia. As you know, everything is digitized now. So whatever photo you are taking, whatever snaps you are taking by your mobile, they are also being converted into digital form, and it is very easy to save also. Right. So those are the say uh, advantages of using digital circuits. Now, why not digital? Because more bandwidth is required, synchronization in electrical circuit is required, and we have approximated information. We don't have the exact information. We have approximated information. Right? So we can't say that the whatever digital signal we have converted is the exact way. So, right? So we are using the approximated circuits of it. So we are using these sort of circuits which we call it as analog to digital converters. Now for that we require a sampling circuit which obtains the value of discrete points in time. So it will store those points. And that is actually nothing but the quantization. That is non-linear transformation that maps continuous values to discrete values. Right? So quantization is actually it is going to give you some points whose those points or those voltages are to be converted into digital. Rest it will leave. So that particular part is called as quantization. And we need to have the samples of those those analog signal, right? I will show you that. So this is the analog signal, or we call it as the continuous signal, which is changing with respect to time. And we need to take their samples, and this is to be quantized, and it is to be converted into discrete time or discrete values, like the codes or bits, right? And in between, we are having discrete time continuous values And this is the circuit. This is actually the sampling theorem that we are not bothered about, so we won't go in depth of that. Nyquist sampling theorem is there, so we are not required to go through this. This is a sampler. This is actually the circuits which is supposed to give you the samples of this analog signal. So as you are able to see, we are having this time periods T1, T2, T3, T4, and T5, and these are the points. After sampling, we will be able to get these sort of points, and they are supposed to be converted into say digital form, right? So gated samples. Now, how these are being sampled and how they are being used, so that is done by using a switch, right? So switch can be used in that particular case, and that switch is being uh, on and off by using a clock sample. So giving it the on and off time, as I told you earlier, that can be the circuit can be switched off. So this is the analog signal that we are having, which is changing with respect to time continuously. And these are the samples. These are the clock pulses that we are providing to this switch, and accordingly we'll be having these sort of signal, right? So this will be actually having the time period t that is being taken by this the samples, the clock pulses which are provided converters, right? So these are the gated samples. Now gated sample and hold circuit. Now this is again a very nice circuit. I'm just telling you the brief idea of sample and hold circuit. Then you'll actually see the sample and hold circuit. So this is that analog signal, and these are the clock pulses which are being provided. And this is a capacitor. This is very important. See, so whenever the switch is on, the capacitor is going to charge, and it is going to hold that particular signal to a certain moment. And as soon as the switch is open, this signal is going to be transferred to the circuit, to the analog to digital converter to be converted. Right. So what we are supposed to get, we are going to get all the uh, analog signal, almost all the analog signals. Right. So we won't be missing some part of this analog signal. That is why we require this sample and hold signal. Now let us see these are some more impulses. Right. So impulse samples we are having like this only. So we are using now pulses, right? A small flicks of say ramps of the which are being provided to the switch, right? So we are supposed to get these types of signals. Now the sample and hold circuit. This is of our most important because we are going to use this uh, by using op-amp. So now we are having this analog signal, and this black line which is being shown over here is actually showing you what is quantization. So this is how quantization is done of the analog signal. I guess you understand what is analog signal, right? Which is changing with respect to sound. So this blue line represents that analog signal, and this black line is giving you quantization of that, right? So it is being say um, it is being divided. The samples are being divided by that. So this is quantization, and this is what I need to show you. This is what is shown by this quantization. So quantization is nothing but the making and breaking of pulses. So at a particular level, it will remain zero, and then it will become high, and then again it will remain zero for something, right? So similarly, it goes on. So that is called as quantization, making say samples of them. So this is error again. We won't go in depth of that. We just need to have this circuit. So this is data converter circuits, which again is not. I have already told you that this capacitor is going to charge. Now the circuit. Uh, yeah, this is again important. Uh, this is an analog to digital converter circuit, which we are supposed to apply a certain voltage, that is the analog signal, and at the output we will be having the number of bits coming out of it. Right? So whatever the number of bits here they are showing 1, 2, 3, 4, 5 up to n number of bits, right? So that number of bits are supposed to give you the digital output. Now this digital is again can be converted into voltage, which is uh, by the circuit which is called as digital to analog converter circuit, which I guess you have already studied. So this is the analog signal which is being provided, and it is being converted into digital signal. Yeah, this is the circuit which I was expecting to tell you. So this is a circuit where we are employing two operational amplifiers. Op-amp, the input signal is provided to the non-inverting terminal of the op-amp, and we are using this switch over here. Where here we are also going to connect the field effect transistor or a simple transistor. It can be used as a switch, right? And we are providing the clock pulses from here. So this is going to switch on and off, and here we are having the capacitor over here, which is supposed to charge and discharge according. So this is a simple circuit that is used for a sample and hold circuit, right? So sample means this switch is going to get the samples of that analog signal, and the capacitor over here, which is connected in series, is going to give you the is going to hold that particular level, particular signal for certain moment, right? So this is the main circuit. Now this where it is shown as a switch. Here we are going to use a switch which is actually fade switch, or say switch with the transistor, right? So the same circuit can be shown like this. Yeah. So this same circuit is like this. So we are having two op-amp amplifier which is used in non-inverting mode, and we have applied the input voltage, that is the analog signal, to this point, and then uh, we have used this fade as a switch, right? So fade as a switch, and we are controlling this by providing the clock pulses to this fade. As we have on, then this fade is on. When we have off, that is zero. When we have one or high, then this fade is on. When we have zero or say ground, then it will be off, right? When it is on, this capacitor is going to charge. We call it as a holding capacitor, right? So this is going to hold that particular voltage for a certain duration of time when this is on, right? It is going to be charged. As soon as this is off, right? So whenever this is off, now this voltage which is being stored over there here in the capacitor, this is going to be discharged by through this amplifier, and the output is given to the AD converter, that is analog to digital converter. So this is a simple circuit which is supposed to be added in front of the analog to digital circuit, analog to digital converter circuit, right? The analog signal and the sample analog circuit, and then we will be having the ADC, that is analog to digital converter. I guess you have understood. If you have any problems, let me know. Where we are going to use this circuit, we are going to use the circuit between the analog signal and the analog to digital converter circuit, right? In between that, what is the main purpose of using this circuit? To store or to hold the analog signal for a certain moment, during which the analog to digital converter circuit is converting that particular voltage, right? So what happens? The signal is too fast and the ADC is too slow, right? Analog to digital converter is slow because we are having many circuits inside. Still, the point which is to be digitized comes very fast. So what happens by that time? What we'll do? We'll store that particular point in this capacitor. During this time, the ADC is going to convert some other point, right? While it converts, then we'll send this portion or this voltage, right? So this circuit comes like sample and hold circuit, right? So we are making the samples of that circuit and we are holding the samples in this capacitor, and this is being discharged by through this operational amplifier. This is again a non-inverting sort of. So this is the simplest circuit with respect to this circuit, where it is not shown that which type of switch is being used. So actually, this is a fade switch, or in some other cases, we might use a transistor BJT, right? So BJT can also be used over here, and the rest of the circuit is same. So, to be say I want to share one of my memories with this. This was the first circuit that I got in my MSc when I have taken admission in MSc first year in campus. So this circuit was given to me as a practical. So I was supposed to give a lecture on this, seminar on this, and then I was expected to implement that this circuit have fruitfully given that and then actually implemented this survey. So this is what I was expecting to implement in our semester four also. So we have many circuits over there. So we should understand the designing portion by the students, and that is the main aim of keeping this whole transducer paper and the circuits over there, so that you might be able to design those circuits in future, right? So this is all about the today's class. If you have any queries, you can ask me, or anything which you want to repeat me in this lecture. We have again 10 minutes to go. So yeah, if you have any questions, you can ask me on that. Anybody? Yeah. Hello. Yes. Any questions? I guess you have understood everything. Hello. Thank you. Thank you very much. Just what we are studying today is the sample and hold circuit, and for that we require this uh, digital circuits. Yeah. So what is analog and digital signals? I guess you have understood what is analog and what is digital. Do you have any problems in this? Analog and digital signal. This is analog, which is changing with respect to time. It's actually again a voltage, and this is to be digitized, right? Digitized means it is to be converted into digital form, digital codes, right? That we have studied in binary numbers and all. So equivalent numbers that is shown over here in 3 bits. Right? So this is analog and digital. That uh, we require to convert this analog to digital signals, right? And for that we don't need to grease this voltages in between the two samples. So for that, we require this circuit that is called as sample and hold circuit. These are some of the definitions. Why digital? These are some of the advantages of digital circuits, digital signals, and why not? Why we should not? These are the drawbacks of digital signals. More bandwidth is required, synchronization in electrical circuits, and we are having approximate information. That is the main drawback of that. That is not the exact information that we have. So sampling, how to convert analog and digital analog signal to a digital form, that is we require sampling, and then we require the quantization. Right? So this is the say the block diagram of that. Yeah. So this was the block diagram. We take sample, then quantize, and then we convert it into analog. This is the sampling theorem. We are not bothered about. We don't need to learn this. Then these are some of the samples that have been showed over here. Yeah. So this is the analog signal, and this is actually again the portion of that matrix theorem or sampling theorem. And this is how the concept of gated samples we are having. So we are using a switch with a clock. As well as using this, we are supposed to get this type of a wave. This is actually the pulse code modulation, which is used in communication part. So pulse code modulation. Remember this. This is what we are expected to learn in the next semester, semester 5. We are having a whole chapter, a whole paper on communication. Right. So these are gated sample and hold, and this is sample and hold. We are having a sample, and then we are holding that sample in this capacitor. We are storing the charges over there. Right. So this is sample and hold circuit, and this is input. This is sample and hold. This is quantization actually, and error, then data converters, and yeah. So this is the circuit of sample and hold that is using op-amp, right? So we are using op-amp over here. This is non-inverting terminal. This is inverting terminal. We have feedback. Here we are having a switch, which we call it as a phase switch. or we can, in that case, we can use a transistor as a source. So here we are going to provide it with a clock pulses, and when this clock is high, then this capacitor is going to charge. When this clock is off or low, this will be switched off, and this will be open switch, and this capacitor is going to discharge to this op-amp, and that particular voltage is being utilized by the analog to digital converter, right? So this is one more circuit we are having. This is actually the simplest circuit that we can use for as a simple and full circuit, right? So we are having this analog voltage. We are inputting analog voltage over here in this op-amp, and this is being sampled. This is a holding capacitor over here, hold that particular data, and this is switching fade. Right here we can use BJT also, bipolar junction transistor also. So this circuit is going to be used in between the analog signal as well as uh, the analog to digital converter circuit, right? In between that. So thank you for listening. If you have any queries, let me know. We can share that in with you. So I guess you have understood. Tomorrow we are going to learn hopefully instrumentation. Thank you very much for joining, and I hope you have understood this topic of ensemble and whole circuit. So by that time, we'll have another lecture. Stay home, stay safe, take care. See you soon in the next class tomorrow. Thank you for watching.